Hello guys, hello. Welcome to the stream. Welcome to the stream. It is morning, it is Sunday morning. And welcome. It is background. It is virtual background. It's not actual background. So my actual background is so, how can I say? So diverse. Very good. We have good connection. I think my audio is good, right? I think audio. Seems fine. Yes. For last two streams, we are struggling to solve this problem. Keyboard input. So now today, let's finally fix this problem. Okay. I figured out that using this stuff is useless. You can just delete it, okay? And win one clock cycle. So our logic is fine. That we take and write into memory. Take and write into the memory, okay? So here, we create a temporary place in the memory. We call it, its address is FFF hexagon. And then we create a label, we call it loop. And we assign A and assign a D. And we check a D if it is 0 or not. Because if it is 0, it means we haven't pressed anything. So it means we will go back to here. So look, if I press key, so value changes here, 6 and B, right? See? So it matters. So it matters. Therefore, we use this one to, it's one kind of if statement to check. So this is used for it. And the second case is that when I press this one for long time, it doesn't change, right? It stays 68 and 68 for several clock time. So we need to create such things that it should detect that thing. And if it is repeated, if it is the same value, we should not save. A equal to the temp, A equals to the A star, A equal to A minus 1, D is equal to D minus star A. Before here, let's go to here. So we go to address of this place. We go to the address of this and we read the value, and we go to the address temp and we got a and we write D to the A. What is D then? D is a value. 68 or some kind of this kind of hexagon value. So what we need to do here? We need to write it to the address, this position. Now we wrote to the 1000. No, this is our D, A equals to temp. What about if I say, A equal to the 1000 if only if it is not empty. G and E. Does this work? No. Why it doesn't work? Syntax error. Syntax error. Why syntax error? Because we cannot combine address and GNE. Maybe. If star is empty, is 0, we go to the next. Go to the next and write to the star a the D value. Okay. And we will say a equal to a plus 1. And I will go to a equal to temp and star a equal to the a. Can I do something like this? Reset and run. Oh, interesting. Should I add this one? Really? Oh, this is stupid. This is stupid. Look. What if I assign it to the D? Oh my god. I closed by accident, sorry. Then game. So here I can say, so D equal to A plus 1 and D as run. A equal to that value. Okay, it jumps. Say A equal to loop. Does it jump? It jumps. Then A equal to the loop. Does it jump now? Okay. Sticky. Shift A. Okay. Now works. I change to the B. Okay. J. Seems working, but address is not changing. A equal to the 1000. Okay. Look, the value address for the A should be stored in this address, not in this address. This address is occupied with the value from the keyboard, so A equal to this one. We should say something like, you know, star A or this one. This is address, right? Legitimately, this is just address. So I can assign like this. What is in temp? Thousands, okay. Go to the temp, go to the A star, and this is the value. Okay. Should I use this one? I don't know. We'll just write. Okay, we have a problem. Where? Here. I cannot assign like this. It's definitely wrong. But instead, I can say A equal to 0 x 1000, T equal to A. Okay. Seems like kind of working, right, guys? Seems like kind of working now. This loop is also working. I'll change another value. So let's check the solution. Okay. Current diagram doesn't comply with the specification. Press A for 10 clock cycles. Expected memory and 1000 A to be x41. Guys, it's like that, no? Okay. We got 22 cycles. 22 cycles. I want to reduce it. I don't know, maybe this is necessary or not. Okay, it's necessary, otherwise it turns up, it stops. It stops. This is important, that is important. And here. We don't need this one. Okay. D. Yes, I enter it from here. But reading twice is bad, right? We are reading here once. D minus star A.
dolduruyorsa
Ya önce D minus hop star A. Can I use this one instead of just instead of this other one? Let's check it. Okay, now it's because it's 0. Now it's like that. Now I press sticky shift A. Okay. Oh no. A equal to tab, I equal to the star A equal to A minus 1, A equal to the loop, A equal to the loop, and then it is done, it does work. I can use like this, but I can use only but before. But do we need this one? Seems like yes, we need to have it. Oh no, it's not working. T minus star A. Yes. So here I don't have a right. I don't have a right to write here the A equals the loop. So we have temporal address and we have a 1000 and we take it to the D and we write to this address 1000. Okay, this is clear. Can we simplify? This is the simplest because we cannot directly say D equal to the 1000. It violates. We can only assign D through A. We can assign star A through A. Now then we have a label loop and we assign A equal to 6000 and we get the D. And we compare like this. It is arithmetics now. I need to speak. Yes, I need to speak here. I get the address. Fine. I check the address based on the if it is 0 or not. Do I need to check? That's the question. Do I need to check if it is 0 or not? If it is 0, then it means nobody pressed it. A equal to temp, A equal to star A equal to A minus 1, small. Q, G, A, Q. Okay, this is, it seems this is unavoidable. And this one. Okay, this one means helps to for us what? It helps when the value in the address, when the keyboard which I press changes. When it changes, it will continue. It will allow. Otherwise, if it's not changing, it will not allow. Oh, this logic is stupid. I think this logic is stupid. What if I want to press twice A? We need to come up with better idea. A equal to 1/6000, D is equal to A star A. Simple thing I know is define new thing. A equal to them, A equal to star A. A minus 1. D minus A. D minus star A. That is D. D equal to D minus star A. D minus star A. A equal to sub yes, D. No, I have no idea here. Let's ask some help. First you need one address which you increment by 1 in every key input and then go to the store the input. To start the code you should set address up to start at similar in increment at every full cycle. I suggest loop address to save instructions. Secondly, you will need a second loop to prevent holding down key from giving multiple inputs. This should only go back to the start once the keyboard is equal to 0. As the second one is not implemented, guys. For last 4 days, lol. Thank you. I will give this a go. Okay. This logic is wrong. Well, it's pressed, it's different value, you should write it, okay? Is continuous press and then allow, otherwise don't allow. A equals to the 6000, D is equal to that one, and we write to the address. But can I write to the address? Yes. A equal to the star A. Right? Click. And guys, I assure that this is true. This is writing to the disk. Writing to the D address. Right? Getting from the D address, right? This is what I want. Oh, it's Korean language, guys. Star A is equal to what? D. Right is done. We just fix this problem, guys. Quickly. Should do more things, okay? Today it's lovely, awesome day, okay? Okay, we are reading from this address to the D value. We're checking D if it's 0 or not. I don't like you. and then we are writing to that address from the temp. Yes, makes sense. Should I increment? Should I increment there? Increment the address like this. Should I do it there? Label is continuous. Okay, let's do this one. Okay. The loop will continue until it is released. Loop will continue until it is released. Okay, it means we have a D value, right? Okay, let's commit it. Oh, label is label. Of this label is continuous press. That means a. No, it means we have a D value, right? We have a D value. And then if this D value changes, then we should release it, right? If it changes. If only if it changes, then we can, you know, I think we can just read from the temp. Start D minus start A. Oh, absolutely what I want. If it is 0, we should go back. I mean, we should just go to this place. So it means is continuous press. And go back. Once if it is not continuous, one it goes forward, we need to go to the next value. It means A is equal to temp, right? A equal to star A plus 1. Can I say D? Then can I say just star A equal to that one done? Done. Maybe true, maybe wrong. Let's run it. Okay, now it's 41, right? Everywhere is GEQ, right? Okay, GEQ means if it is 0, go back to that loop. If it is 0, only if it is 0. Yep, let's take it. Star A is 41, okay. A equal to the loop. We are passing. We are reading the temp. It is 1 and 6. Star A equal to the D. Why? Okay, we are writing the D to the star A. Okay. What is it? 0041. Okay. I'm reading that one. So we have a D value. It is 0041 minus star A. Star A at I don't know the value, but output is F03B. F03B plus 0041. Maybe it will result in star A. It will result in star A, definitely. So then we store this output to the D. So D now is F03B. But actually it should be 0 because okay. This temp is new temp, right? Okay. I don't want to change it, but oh wait. We forgot this stuff. A equal to 10, okay. A equal to the star A minus 1. Yes, I am doing that. D equal to the D minus star A. Okay. We have a temp and we get the real address of the temp, and then I get the value from the A address, and then D minus that value equal to the D, and then I compare D, either it's 0 or not. Sometimes it works, but sometimes it doesn't work. I mean, in one case it works, in another case it doesn't work. Because D value changes here, we assign D to new value. Oh, then we should not assign like t here. It's bad. Finally, we fixed it, guys. Finally. Alhamdulillah. So what is the idea? So we struggled for 3 days. 3 consecutive days, and on the last day we fixed it. Turns out we don't need this guy. So yesterday we solved it actually. Yesterday. But we had, a bit different approach. Because we were focused, yesterday and day before we had only one label, one instruction set, okay, one loop. It was repeating only one, but here we have 2 loops. One loop is responsible for what? The first loop is that it takes care if you write actually a keyboard, if you press actually keyboard or not. That's the first loop. The responsibility of first loop is to define if you are pressing a keyboard or not. And label 2 is responsible that either you released it or not. That's it. Simple. Oh, next. PC is past last instruction. The robot is in the labyrinth facing north. Robot is stopped. Obstacle in front. Okay. I'm robot and in front of me there is an obstacle. I am stopped. Something like this. So what we should do? The computer is stuck in a labyrinth on Mars. Whoa. Write a computer that write a program that will make it escape the labyrinth. The computer has connected wheels and a forward obstacle detector. Input output to the wheel and detector is memory mapped to address 7FFF. Output signal to the peripheral 234. The movement turn is started when a bit is charging from 0 to 1, but will take a moment to complete. Input from peripherals 8, 9, 10. Obstacle detected in front. Device is turning. Device is moving forward. Okay, what should I do then? Should I help to the program to turns left and right? Okay, we have a RAM. We have 4 addresses in the RAM. We have memory mapped I/O. We have register ADPC, an instruction and LU. We can use we can use a label. We can define something. It doesn't cost that much. Actually, that doesn't cost anything. Mm-hmm. 7F. Move forward one step if it is 2-bit. Where is the peripherals? How can I reach it? What is its address? The movement turn is started when a bit is changing from 0 to 1, but it will take a moment to complete. Input from peripherals. What you can do? If robot has an obstacle in the front, it can do what? It can turn right or left, okay? Turn right or left. Then I want to tell to the program to the program to turn to left. So it means which address I should say to? Where? Which address? 7. Okay. T equal to A. Now let's say A equal to the 2-bit. It's D. Okay. Okay. It does brute force, like robot goes front, this obstacle. We have 2 ways, this way or that way. And the model choose this way, and then go to this way, and then go to another way. So it tries a lot of approaches. It does many trials, and if it does many trials, and it can kind of escape this labyrinth. So now I am telling to the program to go to the to turn left. To turn left. Or maybe we should do something else. Like we have a RAM, right? We have RAM 0000 0001 0002 0003, and we have inputs. Reset 100. What is 100? We should say, it's simple here. What is the output? What is the input? So, respond respectively. Okay. So we should respond respectively. Memory mapped IO. Okay, I like this name. What was the name? Okay, define MMIO. Oh, good name. Good name. Define MMIO 0x 7FFF, and then input equal to oh, I cannot. Unfortunately, I can assign to that value. This is the output. -8. Can I do like this? No. Okay, I cannot make arithmetic calculations in here. What if I write to the D and do this D? No? Yes, it seems like I cannot do. If device is turning, what I should do? Wait. If device is moving forward, do not touch. Or should I take and write to the RAM? Should I take this all and write to the RAM? This address. Then what does it give to us? Okay, let's ask a question. What does it give? So here we have requirements. Look, we have a robot. The robot is going in. It has a road. It has a path. But if it has find the obstacle in the front, it has two options: or either left or either right. Which one should we choose? And then we have another input from peripheral. If it is oh, wait, guys, look. We have 4 ramps, right? And we can move forward, left or right. Yes, that's definitely right, correct. A equal to the MMIO. Yes, okay, makes sense. D is equal to the star A value what we can do. One idea is just to write to the RAM directly. No, like A is equal to the 0, 0, 0. And then star A is equal to the T. But we have 4 RAM, right? Why 4? Because I think it is because we can move forward, left or right or backward. In labyrinth, we have always a solution. Sometimes we have one way, sometimes we have 2 ways, sometimes we have 3 ways in labyrinth. So if we are stuck, if we are lost in some kind of path, we can rotate, like like once, twice, third, and again one more. But it turns out that it depends. It depends on the situation. So we should somehow present that logic idea into this assembler code. A equal to the 0, 0, 0, star A is equal to the D. Oh, D. No. Maybe we should do it before. No. A equal to the MMIO, D equal to the star A equal to the A, D equal to the D minus A. Okay, I have no idea, but, if we cannot solve one thing, we should not stack. Okay, we have so many things. Display network, push D, pop A, push value, add, sub, neg, add, or. Stack machine, high level language, code generation. Code generation? It is AI, no? Let's play some games. Takomachi. Typing. Typing master tutor. Okay, this one. Oh, I always make mistake with space bar. Mistaken. Oh, because you know, it's because of the VIM. It sucks. VIM sucks. VIM sucks. VIM sucks. Just a moment. I will move the Safari here. Okay, we have Safari. Okay, now fine. Now fine. Oh, Sudoku, Suzuki. So this is special typing class. You know what is special here is that it's very, very simple. And the letters here are white colored. So actually I'm typing here. So I'm typing here, but you know, background is white and the letters are white. They are just invisible, and they are on purpose like that. Oh, I typed 3 times. I'm very happy that we fixed the problem. Fix the problem with the keyboard, finally. Low level are difficult. Okay, I have one problem. Oh, one mistake. No, I haven't written it. Actually, I was writing. Why so many mistakes? Okay. Calm down, calm down. Done. So, let me to read hacker news. We have update from yesterday's stream. We have now this, oh, you cannot see it right. Now we have this machine, this bot. We call it JetBot from NVIDIA. Manufacturer is China, but this nano and the whole logic software are from NVIDIA company. The camera, antenna, etc. These wheels are from China. What's here? Writing speed of light flash attention for 5090 in CUDA C++. Oh my god, I want to see it. What happened here? In this post I will walk through how I learned to implement flash attention for 5090 in CUDA C++. The main object is to learn writing attention in CUDA C++, since many features are not available in Triton. Okay, I don't know what is this. Floating points, mixed floating points, mixture, CM120. What is flash attention? So we have attention. Attention is just a formula where we have a key value and key value query, and then you have a softmax, and you get the multiplication dot product between two of them, and then you normalize them and apply softmax, and then multiply with query or something like that. This is attention. This is basic attention. But flash attention, flash stands for maybe it's like quicker, faster, efficiently. What is the formula for flash attention then? Okay, torch CDPA. Yes, query key value. We have 3 inputs. And output is only one. We apply attention. We do the value. We have a dot product between value and attention. We have a softmax, and the thing comes from where? It turns out that we have this D value, and D value is responsible for scale, and then we have a dot product between these two guys, and instead of dividing, okay, this means root square of D, and then we multiply the root square of D to this dot product. Q shape -1 means this dimension. So it turns out this is the flash attention implementing in C. Wow, it's easy, interesting. What about if we implement in compiler, in assembler? I would say it takes some time, but it's definitely possible. But if you ask me, is it worth it to implement on such a low thing, on assembly level? It is. Implementing these things in assembly level may be not that efficient. This is now fancy formulas. Oh, this is some kind of a logic, like M, M, A, M. Happy writing kernels. Yeah, happy writing kernels. Good. Now one of the upvote. Static sites. Why? We have HTML. Okay, Docker. UV is environment controller. Python is a language. CAD, I don't know. Docker is a virtual simulator. No, I can say emulator. Virtual emulator of another operating system. Yeah, we don't need that much things, you know, for website, especially for static. Line scan camera image processing for train photography. How can AI identify a cat? Based on pixels, based on the weights. What is this? I don't like it. Hide. Internet archive mirror no longer available. EXIF. You know what is EXIF? If I don't mistake, it is image extension. Okay. In EXIF, it is on iOS. You have location. You have the what is the iPhone you took the photo on. What is the date? What is the camera specifications? What the time was at that time? And they're just done. I think done. This is whole information of the image. It has auto balance for 52 standard, GPS location, etc, etc, etc. Oh, what is this? Maybe it's in Vision Pro. Oh, this is amazing. So it's not Vision Pro. The person is saying like that. Interesting. Good. Upward. What? 60 billion. iPhone will check in Texas Instruments. No, actually, iPhone has many components from the Texas Instruments. I mean, what kind of chip is it? Interesting. Just 2 days ago, right? Wow, chips. Let's update. Oh, many mistakes. Arduino OS? Clock to on Hugging Face. Actually, guys, I'm very confused how the clock works. Let's Google it. Wikipedia sometimes is not good source, but overall, I mean, I have idea how to build computer now, about hardware, about the circuit, about the NAND, about like logical gates, arithmetical gates, but in the end of the day, it matters. The clock matters. If you look to the different computers, different processors, each processor has different clock rate. As if you have higher clock rate, it means your computer is more faster, more better. If you have a lower clock rate, it means your computer is slower. Your computations overall are smaller, and I assume GPUs has no, not GPUs. Overall, our like these iPhones or this latest chips has huge clock rate, and because of that, their computations are quick. GPU, I assume, and CPU, they have almost same frequency for clock rate. So let's okay. before reading it, let's talk about like how actually clock rate works. So I know the information that, for example, this has maybe 5 megahertz, the rate of it. Okay, why not one watching? Why only one watching? Okay, hello guys, edit, yeah, power, yeah. So clock rate. So every circuit has a clock rate. Every modern circuit. So I have heard it consists of some kind of. We haven't built the clock rate actually. In our series of building computer, we haven't built it. Okay, we did this one, guys. So we did NAND, invert, AND, OR, XOR, etc. But so in this time we didn't feel a necessity for the clock rate. But when it turns to the memory or to the processor, we need a clock rate. Clock rate was basically used to synchronize between. No, it was used to synchronize operations inside the circuit. Correct me if I'm wrong. So, to sum up, the clock rate is used to synchronize each operation. So, in the processor, it is like the power is going, right? And the circuit has a power, and we have a small little switches, right? Switching. If it is connected, the power will go on. If it's not connected, power will not go on, right? So based on this, there is a calculation. So these calculations should be at the same time or should be together. So in order to provide this synchronization of these all actions, all operations, we use a clock rate. So now it's time to check the result. So we need to Wikipedia. Clock rate, clock speed in computing typically refers to the frequency at which the clock generator of a processor can generate pulses used to synchronize the operations of its components. Okay, guys, it seems we are correct. So, used to synchronize the operations of its components. I hope it makes sense, right? Does it make sense? Okay, we have 5 viewers. Good. Instruction sets. Yes, we have instruction sets. Instruction sets can be memory access, or it can be arithmetical calculations, or it might be logical calculations, assigning to the register, writing to the disk, writing to the RAM. That are all instruction sets. But how does this clock generator work? What can generate a clock? What makes a clock to generate? Is there a special method? Interrupts as well. Interrupts. Or kilohertz. Personal computer in 17th had clock measure in megahertz. In 21st century, the speed of modern CPUs is commonly advertised in gigahertz. Yes, in gigahertz. If I don't mistake, in Apple, in iPhone, they use 4.5 gigahertz. iPhone a chip clock rate. Where? Should I go and check it? Okay. Here we have an assistant. 4.4. An accelerator circuit is used to generate the clock cycles. Okay. Oscillator. Crystal frequencies. What is this sonnet? Does it have good resource? Instructions, requirement. Okay. If you have any links, share a link. We can visit that link. Okay. Oscillator circuit. Okay, I see. Okay. Electronic oscillator is an electronic circuit that produces a periodic, oscillating, or alternating current signal, usually a sine wave or square wave or triangle wave powered by a direct current source. And is this provide 5 gigahertz to the modern CPU? Look what it has. This is power, right? This is power. What is this? Resistor? What is TL? Oh, it's not TL. It is amplifier. V0 voltage goes into the feedback network, and then it goes to amplifier, and it works in such a way. Interesting. Simple explanation, very simple explanation. Okay, an oscillator is a circuit that converts direct current from DC source into the continuous alternating waveforms, typically without any external inputs. Okay, good. Makes sense. So we have an energy, and it takes this direct current from DC source in the chip, in the computer, and then it makes it continuous alternating waveforms. Okay, good guys. Harmonic oscillator and relaxation oscillator. Main types of oscillator included. So many types. piezoelectric effect. GTX to produce. It's more electric engineering. It's now electric engineering. Okay. Piezoelectric effect. What is this? The ability of certain materials like crystal or ceramics to generate an electric charge when subjected to mechanical stress, such as squeezing or pressing. Reversible, meaning it applies electric field, can also cause these materials to change shape. Okay, the idea is based on this one, right? So the idea of using oscillator is based on this piezoelectric effect. Interesting. 1880. Good lesson for me today. Good lesson for me today. Okay, we have 4 viewers. I think on Sunday it is like we have good number of viewers. Everyone is at home maybe. Okay, we now in software. I'm here. I don't want to solve it. We have functions, memory, conditional, higher level language, stack machine. Let's do some reading. Okay, Grok 2 contains weight of Grok 2. Now we have Grok 4. What is a Grok now? It is Grok 4 only, yeah. Grok 3, Grok 4. And we have a Grok 2 here. What is the weight? How large is this? Okay, we need the server. CG Lang interface engine. 8 GPUs. Each with 4 gigabytes of memory. Look. 8 GPUs with 40 gigabytes of memory. It turns out the A800 or what is this? A100 or what is this? It's 8 gigabytes. It's small. Is this AMD? Gaming Radeon RX. Maybe. 16 gigs. 32 gig. No. Oh my god. So what is the size of the model? 72. Oh my god. So much. Yeah, they are powerful, you know. I saw this one. Gaming series GPUs are not used for this, so yeah, you are right, definitely. It turns out that this, where is it? The gaming GPUs like 4090 or 3090 or 5090, they are small, they have small memory. But the specific A100, A100, H100, they seems suitable. Only they. So it means just only NVIDIA. What about AMD? AMD GPU 7900 memory. What is the memory size? I think they are also small, but let's check it. Okay, what is the point of 24 gig VRAM? It has 24 gig. What is this? Arduino OS is operating system for Arduino which support real multi-threading, exceptions and hardware abstraction. The kernel of Arduino OS is entirely written in assembly and C and optimized for minimal memory usage. Maximum thread on device 1 system thread. And Arduino Uno 20 threads. Arduino Mega 90 threads. We have Arduino OS, guys. It's so powerful, so powerful. So they wrote it in assembly and C. See how hard assembly is. I mean, not hard. The assembly is, you need to adopt it. You need to be patient, really patient. Look, this is assembly code. You should feel each component and like what is this. You should be taken in with these registers and memory, and then doing this logical and arithmetical things in a very, very specific way. Like you cannot look from the above. You should go really dive into the small thing and think only on that small area, only on this box. And it does require good knowledge. It does require like good skills, good practice. I mentioned it. So they did it 8 years ago. Only one guy, so it's not open source. So only one guy did it. Okay, we have issues. Pull request, no pull request. Okay, it seems like nobody using it. I did get compiler error on init context switch, so I changed it. Switch context internals, and all works. You might consider formatting your JIT so that zip download easily install into Arduino IDE or Visual Micro IDE using install Arduino pip from zip. Very nice job, thank you. I want to read it. So what? How many components? Okay, not that much, not that big. Xproj, is it written in Xcode? Seems like. Guys, look. CPP means C++. .h means header. dot INO. INO. What does it stand for? Initial point of running. Initial thing. I think this is metadata. This one's metadata. Seems like metadata, or maybe this is also metadata. Maybe this is a start. Nope. License. It is Arduino sketch file. Yes, Arduino example file. Yes. You just take it and run into Arduino. Yes. Arduino used to have this one. INO. Include kernel initializer. Where is the kernel initializer? Memory usage. Pragma include external include kernel. Okay, this is header. This is actual implementation. Initialize kernel. Main function. Kernel initializer. Timer 1. Initialize. Timer 1. Attach interrupt. And then kernel. C. Okay. This is C code. If they have Arduino OS, then does they have a OS for this one? ESP 82 ESP 8266. Okay, we have a low battery. I need to plug in. Okay, now good. Mongoose OS. Apache. Dr. Bomb was not that bomb. Previous guy, no? No. Dr. Bubble. So many doctors, huh? I love this kind of thing. I love. Okay, I need some patience. Some patience. So, before diving into the assembly code, guys, let's read some Apple security. Apple security documentation. Not this one. No, not this one. Apple platform security. Guys, do you want to read this one? I don't think Arduino support OS as it's basically just a microcontroller, so it can only run single program, but RTOS is capable of running for multitask, which is done by multi-threading, which I'm guessing what the Arduino OS repo is built on. I guess, I don't know. Yes, Arduino is a microcontroller. Arduino is microcontroller, but operating system for Arduino, which support real multi-threading, exception, and hardware abstraction. Entirely written in assembly. So no, it's used for Arduino Uno and Arduino Mega. So we can install this OS on the RTOS. RTOS means real-time operating system. Yes, I think we can install to that. Multitasking. Maybe multitasking is same as multi-threading. But I haven't worked with RTOS. RTOS. I know RTOS is used for drones. RTOS, drone OS. Wait. RTOS is an operating system, or is it? RTOS is it? Is RTOS is operating system, or is it instruction set? Let's read about it more. RTOS, just real-time operating system. Yes. It is operating system. We just download, we install it. Yes. Can I take this free RTOS and install to the Arduino? How do you think? RTOS install on Arduino. We can install it. And also we can install free RTOS on this chip. On the chip which I have now. On this chip seems like. Can you see? We can install on this one also. Then what is the size of that OS? Where I can downloads? Okay, this is free RTOS. Then releases. It is 23 megabytes. This one doesn't have 23 megabytes. Anyway, we can figure out, but I don't want to do this now. Guys, do you want to go and read this awesome, difficult, challenging puzzle regarding the security Okay, we have 4 viewers, guys. Good. So it turns out that nowadays people cannot hack iPhone, but actually we can hack, I think. Actually we can hack, and there are a lot of backdoors, I think, inside this Apple. So let's just read this. Let's read this documentation and understand more about layers of abstraction in operating system. I don't see a reason. So this is prepared in December 2024. So what information do we have here? Okay, 300 pages. Nope. How can I go? No. Wait. Let me to open on this one. Reading in Safari maybe not good idea. Reading here is good. Okay, let's make it bigger. Fine. So we have 300 pages. Network security, development, kit security device management. Those things. Okay. We have several sections. We can skip sections. It doesn't matter that much. Service security, app security, encryption and data protection. System security. So the most interesting thing for me now, I see your audio go to muffled. What about now? Can you hear it? Yes, my audio is connected to my phone. So here it's my audio. Yes, this is audio. So I'm putting here. Okay, my chair is old. It's noisy. So let's read from this page 5 to 197. Apple security research device. Apple security research device means hacked Apple or jailbreak Apple, maybe. Blast door for messages and IDS, secure boot, system security overview, express cards with power reserve, hardware microphone disconnect. Okay, let's go. Introduction to Apple platform security. Yeah, now good. Okay. So introduction to Apple platform security. Apple designs security into the core of its its platform. No. We need to draw something. Annotate. Drawings. Note. Signature. Note. Mask. Speech. Text. Line. It was something like this. No? Okay. Drawings. So this is text, right? If you don't like something, just we can just erase some unimportant information. Building on the experience of the creating world. No, every Apple device combines hardware, software. Okay, this is good. This is good. Yes, hardware, software, and services together. So yes, that's their logic. That's their idea. That is their idea. And security of protection work keeps the operating system and third-party apps protected. Yes, the problem is that hardware, software, the services are work together and designed together. So Apple itself manages this whole things. 1, 2, 3. So it means that for Apple it is difficult to do big things. It's difficult for Apple to move quickly because I manage 3 things: hardware, software, services, and this whole ecosystem. Therefore, they designed Apple Silicon hardware. Okay. Let's do the first one and second one. This one later. Next page. Okay. The security matters, really matters. Especially in iOS, you cannot control what you own, and you just depend on the installing, updating from the Apple. I don't see anything here important. Hardware security. Do you know what is SOC? It includes an iPhone, iPad, Apple TV, Apple Watch, Apple Vision Pro, HomePod, MacBook, etc. No? Okay, now. So, important thing is that secure enclave. Secure enclave matters. It is inside the system on chip. Then what is the ROM? Look, we have a RAM, means random access memory. ROM means random operating memory. We have read-only memory and write memory. Okay, good. AEC engine. Okay, so AEC engine is, they say that AES engine is engine solving encryption and decryption of what? Of files? Of files, description of files. Yes, we can say data better. Files are like too ambiguous. You are right. Data. Okay. They have a chip. And inside of the chip they have this secure enclave. AEC engine, CPU, GPU, I think GPU also, and then RAM is inside. I think inside, yes, it should be inside. I'm not sure. So, and they have a ROM, boot ROM. We have a boot ROM. Ah, okay. Boot ROM means, you know, boot, read, boot, read only memory. See? Done. Read only memory. Can we have a read only memory? M1 series, M4 series are for MacBook. This series are for iPad and iPhone. Okay. Do we know a good definition of kernel in this context? Kernel integrity protection. Fast permission restrictions. System compressors. New word. Okay, secure page table monitor. What is this recovery OS? Oh, this is diagram, guys. This diagram. Secure enclave. It is another system. Cryptographic operations. AES is used for cryptographic operations. Guys, can you see this diagram? So this is the brain of almost all Apple products. DRAM, dynamic RAM, NAND flash storage. NAND flash storage. Okay, so many storages. NAND flash controller, flash storage. Can I say this is disk storage? Disk. Oh, disk. Is it disk? The memory controller? Where is the CPU? Where is logics, calculations? Okay, I see that this is almost 50% of the COS, SOS, SOC, System on chip is occupied with secure enclave. TRNG, I don't know. AES, okay. PKA. I2C. I2C bus is how can I say? It is just a road between communicating of two controllers between two components. It's just a road. It's just a way to communicate, and it has some special logics inside. I2C. Memory protection engine. So we have engine, secure enclave processor. Aha, I see. So AES is everything is inside the secure enclave. Can I see the GPU? Can I see the general overall image of the COS system on chip? For which? A what? Let's see for M1. Okay. Let's see for M1. What is the size? Wait, what is this? It's too small. Okay, this is a chip. What was announced involving data memory? Okay. Speculative execution. Pac-Man. Oh, this is news. This is news. When? A14. Okay, it's on iPhone 12. Okay, iPhone 12, iPhone 12 Pro. How does it work? How does it work? How does this cute dog work? What does it doing? Nope, nope. I have no idea. I don't like the official images. Okay. Secure enclave. Okay, my assumptions are wrong. This is worker. This is worker. This is worker. This is a brain. This is a gate to open for this and this and this guys to work. Okay, let's keep going. Chip block diagram. Let's try it. M1 chip block diagram. Oh yes, this is better. What is this kind? What is this language? En el caso de arm. Spanish? What is a diagram? No, what is this? No. Let's look to this one. Okay, anyway. 8 core GPU. 1, 2, 3, 4, 5, 6, 7, 8. Okay. SLC cache. 4 performance cores. Neural engine. Efficiency cores. LPDDR4X channels. Where is the enclave? Where is the security enclave? Security enclave processor. Security LC. No, not like that. Not like that. Maybe this one is security or this one is security. They are so tiny. Anyways, this is a good diagram. This is good, much better diagram. Thank you very much, Edithia. So now, okay. Secure enclave processor has secure boot. Inside, it has dedicated random number generator and it is own AEC engine. Okay, memory protection engine. So it turns out that the data which is processed in here is stored on DRAM. So they access the memory address from DRAM and process it, and again put it to the DRAM. But they say that they use dedicated region of device DRAM memory, and multiple layer of protection isolates secure enclave protected memory from the application processor. It turns out that there is a memory, DRAM memory, and some portion of it is isolated. It is protected only to use for this secure enclave. Applications or other processes cannot access this area. It is 8:56 a.m. So let's change the background. It means it was morning, now it is day. Maybe this one. Okay, now it's day. Yes, I think of secure enclave as an isolated subsystem that exists on the base COS. Yes, that's right. Secure enclave is that isolated subsystem. Yes, it mainly works for data security and some encrypted key security, I think, storing keys. I would. Wow. AES engine is a part of that secure enclave subsystem. Exactly. A TRNG is true random number generator. Why so many systems? Look, true random number generator. Memory protection engine is isolated. Let's say not isolated, it's like independent from this processor. And it talks to the DRAM independently from this one. And then they have this AES, as you said, and then PKA. PKA means PKA. Where is PKA? Public key accelerator. Asymmetric cryptography operations. What is symmetric cryptographic operations and what is asymmetric? Who knows? Does everyone know? Really? Okay, so here they have secure neuron engine. So I have secure neural engine. Okay. What does it do? It just do Face ID. Oh, they have power and clock monitors. See how it's good. Okay, we have answer. Symmetric uses a single shared key with, while asymmetric uses a public and private key. Exactly, exactly. You are very smart. Yes, exactly. We have a public and private key in asymmetric, but in symmetric we just have a one shared key. Well, I like this one. All electronics are designed to operate within a limited voltage and frequency envelope. When operated outside this envelope, all the electronic can malfunction and then security control may be bypassed. To help ensure that the voltage and frequency stay in safe range, the secure envelope is designed with the monitoring circuits. These monitoring circuits are designed to have a much larger operating envelope than the rest of the secure envelope. If the monitor detects an illegal operating point, the clock in security envelope automatically stop and don't restart until the next COS reset. How to do the reset? Actually, Face ID. Face ID. How does Face ID work here? 2D image, and depth map. It maps into mathematical representation of the user face. SEP OS. iOS has so many small OS. What is this SEP OS? Let's go. Let's check it. Where? OS, SEP OS. Okay. SEP OS in iOS. I see. Why they call it engine operating system? What is AAS engine? Used for cryptographic calculations. So this is a key generated each time in SEP OS. Why I cannot use this true depth camera system? Can I use true depth camera system without can I use this one? Because they have no documentation. Yeah, hybrid model using both hardware and software level design. That's why it's engine tone. Makes sense. Confirms the presence of attentive face. Touch ID security, built-in Touch ID, channel security, Magic Keyboard. Oh, Magic Keyboard works wirelessly, right? Magic Keyboard wireless. Because wireless connection is really unsafe. Yes, they can use, but they can use just to verify. Just use public by public API. Actually, is yes, you are right. The camera, the front face camera has a lot of sensors, so we can use them. But there is no API to use. So actually, the Apple is using by themselves through private API, I think. But we, as a third party, we cannot use them. But there is a way. There should be a way. We should find it. click on it. What is the recovery mode? Okay, there is a boot process. Do you know what is a booting process? Booting process is the first step when you are turning on the hardware. It's common in all hardwares, in Windows, in Linux, in every hardware possible. So in iPhone, on Apple, they use iBoot. They used LLB also, and they say that they use cryptographically signed keys, cryptographically signed components, and they check the integrity of it. If everything fine, then it will load, otherwise it will be in recovery mode. What is recovery mode? Okay, I cannot check it. Heap exploitation. I haven't tried this one. Type confusion. Memory, safe, boot, iBoot implementation. Great. I'm not interested in this one. But actually, in Intel-based Mac computers, you can install Linux, you can install other things, and people did it. But installing Linux on M1 or this Apple Silicon is trivial. It's difficult. It's non-trivial. Oh, what is this? During upgrade or updates, certain information is made available to the Apple Installation Authorization Server. Too much information. Too much information. It's enough for today. Because this is the image of today. Today's image, okay? This is image for today. Actually, no, I found one good website, but I don't remember what was the name. GitHub OS1 from 0 to 1. Desktop. Ah, fine. Okay, guys. What? What? I don't want to do that. Yes, I want to do this one. What is GMP instruction? It is jump instruction. Jump condition. Okay, overall it is 2 hours and 40 minutes of stream. We have 48 viewers. So what we did today, so let's sum up, because I need to have a breakfast and then I need to start my day. So we've solved the problem which we couldn't solve yesterday and a day before. And the problems are becoming really hard to solve, and we should have, and I feel that I am not enough, I have not enough skills. So I did typing, I did reading some news, I did reading a security book a little bit, and there are so many technologies. And today chat was active. I like it. Today people were active. And yeah, so it is 9 a.m. and I don't know what's in your time, in your area. However, I wish you to push your limits. Try to do your best to learn something, to share positive things to people. Try to find only positive things in every action, in every event which happens to you, and just go and study what you like. See you tomorrow morning, inshallah. So, thank you very much. Bye bye.